As early settlers pushed back America's frontiers, their first concern was to locate water. That was key to finding a place that would support them, where they could put down roots, establish a farm, build a town, where they could stay a while. Looking outward toward the frontiers of space, our moon is a likely first step in the journey, and perhaps the first human residence beyond our home planet. Knowing there is water nearby will suggest not only where a lunar colony might be established, but it would also determine how humans might proceed in finding our way outward into the cosmos. Northrop Grumman, in association with NASA's Ames Research Center, is building a spacecraft called LCROSS, with the mission of determining whether water and ice exists deep within craters at the moon's polar regions. It's a straightforward mission, with possibly profound ramifications. In many ways, it is the first step that we humans are taking back into space. Part of NASA's vision for space exploration. The mission destination is a crater near the moon's south pole. Early in 2009, an object with the weight of an SUV, traveling at 6,000 miles per hour, will crash into the cold, perpetually shadowed floor of the crater. The impact will dislodge a significant amount of materials and create a plume clearly visible from even modest telescopes on Earth. Instruments on board the LCROSS satellite and elsewhere will analyze the plume for water or compounds that contain water. The results could have a significant impact on the future of space exploration, opening a new frontier for generations to come. LCROSS is a fast-track, low-cost program that will piggyback with NASA's Lunar Reconnaissance Orbiter, LRO. It will be launched from Cape Canaveral, Florida, aboard an Atlas Centaur rocket. LRO will be detached and head directly for the moon, into a low orbit that will provide us with detailed views of the lunar surface. The upper stage of the launch vehicle will remain mated with LCROSS, swinging by the moon and accelerating into an orbit around Earth. Two or more such orbits will place the pair on a collision path with the moon's southern polar region. During the approach, LCROSS attitude control thrusters will make precise adjustments to refine the orbital path toward the crater that is the planned impact point. This important command and control function is what gives LCROSS its additional name of shepherding satellite. Once the path toward impact is assured, LCROSS separates from the upper stage as both continue their 6,000 mile/hour descent toward the moon. LCROSS rotates to orient its sensors so they will have a clear view of the impact area. Then it performs a braking maneuver using its thrusters to give it a 10-minute separation as it follows behind the Centaur upper stage. This begins the most critical stage of the mission. When the upper stage impacts, LCROSS will observe and analyze the plume of ejecta thrown up from the crater floor by the collision. Data from the plume analysis, which may include evidence of water, are sent immediately to Earth for capture. During this last 10 minutes of the mission, LCROSS will continue on its path toward the crater, sensing and reporting on the materials in the plume as it passes through it. Finally, LCROSS itself will impact within the crater, providing a second opportunity for observers to evaluate the components within the ejecta. The spacecraft at the heart of this endeavor is intentionally low in cost and straightforward to fabricate. Its design and performance are drawn from 50 years of spacecraft manufacturing by the company that was the first to build a satellite for NASA. At the center of the spacecraft is the fuel tank, a recycled, space-qualified spare from an earlier NASA program. The spacecraft structure surrounds the tank, providing mounting surfaces for the power, thermal control, communications, navigation, and control devices that will enable it to carry out the mission. Multiple attitude control thrusters will allow the shepherding functions, adjusting the orbital path through space to ensure a precise, on-target finale. An imaginative approach will be used in the integration and test of the spacecraft components. The side panels will be temporarily mounted adjacent to their facet of the spacecraft bus. In that configuration, all the subsystem pieces, wiring, and control features will be installed. Then the spacecraft can be powered up and fully tested. Only then will the panels be folded up into their final position, attached, making the spacecraft ready for final environmental testing and trucking to the launch site. The NASA LCROSS mission is certain to get the world's attention, far beyond the ranks of astrophysicists and professional astronomers. Amateur stargazers will be setting up on dark hilltops. Many students will be involved in the mission, monitoring the system's status during its 90-day flight, using a former Deep Space Tracking Network antenna to listen to its vital signs. This will be a very big story, and although the event will be of short duration, it will play an important part in reawakening the public to the adventure of space travel, supporting human exploration and scientific discovery. And it will take place right in our local neighborhood, in our backyard. Northrop Grumman is proud to be a part of NASA's LCROSS team, getting an important job done on a tight schedule. Northrop Grumman, working with NASA to help us take the vital steps toward our future.